Welcome back to the Orbital Insights. Today, we'll be discussing the ongoing efforts of NASA and other organizations to explore the possibility of life beyond Earth. For decades, NASA has been heavily investing in the search for extraterrestrial life. They've sent thousands of satellites into space, built scientific labs on the Moon, and drafted thousands of groundbreaking reports on the subject. One of the key tools in this search is the TESS telescope, or the Transient's Exoplanet Survey Satellite. TESS is the successor to NASA's Kepler Space Telescope, and is designed to search for planets outside our solar system, particularly those orbiting bright nearby stars that are already known to have transient planets. The primary goal of the TESS mission is to detect small planets with bright host stars in the solar neighborhood, so that the detailed characterization of the planets and their atmospheres can be performed. To accomplish this, TESS scans the entire sky in the northern and southern hemispheres, looking for small worlds that orbit stars other than our Sun. The TESS telescope was launched on March 20 and began working immediately, and among the 10,000 candidates it has identified so far, are planets that are warmer than Mercury. These planets sit in the so-called Goldilocks zone where liquid water can exist on their surfaces. But what exactly is the habitable zone, and how is it determined? The habitable zone is the range of distances from a star where liquid water might exist on the surface of a planet. To be considered habitable, a planet's atmosphere must meet certain conditions. First and foremost, the planet must have water vapor in its air. This is because if there is an aqueous, water-containing component in the atmosphere, it is assumed that it would be liquid or solid water. The temperature on the planet also plays a significant role in the existence of liquid water. At the lower end of the habitable zone, temperatures must not be too cold, as water vapor would condense into liquid drops, similar to Earth. At the upper end of the habitable zone, temperatures must not be too hot, as water vapor would condense into ice. Another factor to consider is the temperature of the atmosphere's gas composition. The upper limit for water vapor is about 100 Kelvin, or 60 degrees Fahrenheit, still well below absolute zero. And air warmer than 35 Kelvin, or minus 186 degrees Fahrenheit, contains more gases that are more likely to absorb heat and not release it as easily as oxygen and nitrogen do on Earth. The third factor to consider is the atmosphere's composition, specifically the amount of carbon dioxide and other gases. At the upper end of the habitable zone, a planet's atmosphere must not be too rich in carbon dioxide, as this would make the planet uninhabitable. One of the planets found by TESS that is believed to be in the habitable zone is HD 209-458b. This planet is 169 light-years away and orbits a star that is smaller and cooler than our Sun. Scientists believe that HD 209-458b has an atmosphere that contains water vapor and carbon dioxide, making it a potential super-Earth. But how can we be sure that a planet is truly habitable? The answer lies in the detailed characterization of the planet and its atmosphere. This is where the James Webb Space Telescope comes in. The JWST will be able to detect the chemical composition of a planet's atmosphere, and detect the presence of biomarkers such as oxygen and methane. And with the development of new technologies such as artificial intelligence and machine learning, we are getting closer to answering the age-old question of whether or not we are alone in the universe. But the search for extraterrestrial life is not just about finding new worlds. It's about understanding our place in the cosmos and the potential for other forms of life to exist. And this is just the beginning. As we continue to explore the universe, the discoveries we make will shape our understanding of our planet, our solar system, and our place in the universe. One of the most promising areas of research in the search for extraterrestrial life is the study of exoplanets. Exoplanets are planets that orbit stars other than our Sun. And recent advancements in technology have allowed us to detect thousands of exoplanets in our galaxy. One method scientists use to detect exoplanets is the radial velocity method, which measures the wobble of a star caused by the gravitational pull of an orbiting planet. Another method is the transit method, which looks for the dip in the brightness of a star caused by an exoplanet passing in front of it. With the use of these methods, we have discovered thousands of exoplanets that are similar in size and composition to Earth. One of the most promising exoplanets discovered so far is TRAPPIST-1d, which is located 39 light-years away and is believed to be in the habitable zone of its star. TRAPPIST-1d is a rocky exoplanet that is similar in size to Earth, and scientists believe it has the potential to support liquid water on its surface. The discovery of TRAPPIST-1d and other exoplanets like it is a major step forward in the search for extraterrestrial life. But the search for extraterrestrial life is not just about finding new worlds, it's also about understanding the processes that led to the formation of life on Earth. Scientists are studying the chemistry of the early Earth and the solar system to understand the conditions that led to the formation of life on our planet. One area of research is the study of organic molecules, the building blocks of life, that have been found in comets and meteorites. The study of organic molecules in space has led to the theory that life on Earth may have been brought here by comets or meteorites. This theory, known as panspermia, suggests that life on Earth may have originated elsewhere in the universe and was brought here through space. The study of organic molecules and the potential for panspermia is one of many areas of research that is helping us understand the origins of life on Earth and the potential for life elsewhere in the universe. The search for extraterrestrial life is one of the most exciting and important areas of scientific research. And as we continue to make new discoveries, we will gain a deeper understanding of our place in the universe and the potential for other forms of life to exist. The search for extraterrestrial life is a reminder of the vastness and complexity of the universe, and it is a reminder that we still have so much to learn and discover. The search for extraterrestrial life is a journey of discovery and a quest to understand our place in the cosmos. And it is a journey that will continue to inspire us as we explore the universe and look for answers to the fundamental questions of life. Thank you for joining us on this journey. We hope you have learned something new, and if you have, kindly hit that like button and subscribe to our channel for future updates of NASA and other organizations as we continue our search for extraterrestrial life. Until next time, keep exploring the universe.